Play is not just for fun. It's one of the most powerful tools for a child's growth and development. Let me start with a story. I have a cat named Percy. When he was just a few months old, he spent a lot of time playing, especially with a toy mouse. He would hide and wait and suddenly pounce or lie on the floor gripping the toy mouse tightly with both paws and biting it fiercely. Sometimes he'd even pretend I was a mouse and ambush me out of nowhere. I was amazed that he instinctively knew how to engage in this kind of imaginary play without any prior experience. Later, when he was old enough to go outside, he became an excellent hunter. It was clear that his play had been preparing him for real life. Yes, it's true. Extensive research shows that play is hardwired into the brains of both animals and humans. It plays a vital role in developing social skills and helps children grow into well-adjusted, capable adults. Today, I'd like to talk about the importance of play in early childhood and the underlying neuroscience behind it, so that you, as early years educators, can better understand and support the developing mind. How do we engage in play during childhood? What is the real purpose of play? Play is far more than just fun. It's a vital part of how children grow and learn. Through play, children try out different roles, learn how to interact with others, and build essential social skills in a safe and natural way. Long before modern brain imaging was available, Vygotsky highlighted that play and the development of higher thinking skills emerges from a child's interaction with caregivers and older peers. Social interaction is crucial for healthy development. In fact, research shows that the strongest predictor of how well someone adjusts in adulthood is not IQ, not academic performance, but how well they get along with other children. Also, children use imaginative play to make sense of complex world, turning difficult situations into manageable ones through symbolic representation. This kind of play also strengthens their ability to share, negotiate, solve problems, and relate to others effectively. What is the underlying neuroscience of play? One of the pioneers in this field is Jaak Panksepp, a neuroscientist and a psychologist who conducted extensive research on rats to understand the biology of play. His work showed that play is an intrinsic brain function. It emerges naturally without previous exposure. For instance, in rats, playful behavior begins around 18 days of age, even if they haven't had the chance to play before. This is proof that the urge to play is biologically hardwired, not learned. Researchers also discovered that young rats who are isolated for a time showed a much stronger desire to play once reintroduced to others. The longer they're alone, the more eagerly they play afterward. This shows that play isn't just a fun extra, it's a deep biological need similar to hunger and sleep. Play is produced through the coordinated interaction of multiple areas within the brain. Two of the key brain areas are PAG and the limbic structure. First, when children play, they're activating deep parts of the brain that are also used for important survival behaviors like reacting to danger, bonding with others, and making quick decisions. PAG helps animals and people switch between different actions, and it lights up during natural play. This shows that play helps children learn how to handle tricky emotions and situations in a safe, natural way. Second, play also involves the limbic system, one of the brain's older emotional center. While the limbic system helps drive the urge to play, it works together with the more advanced neural cortex, the part of the brain responsible for thinking, decision-making, and social awareness. The neural cortex doesn't start play, but it helps shape and adjust how children play as they grow and learn from other experiences. This means that the desire to play is built in, but the way play is expressed depends on the children's environment and social learning. Research in rats shows that even without a neural cortex, they can still play. However, the neural cortex helps them adapt their play based on age and social context. For example, responding differently to dominant or submissive playmates. In humans, this likely supports how children learn to read social cues and adjust their behavior depending on who they're interacting with. During play, the PAG and limbic system, both primitive brain areas responsible for initiating play, work together with the more advanced cortex. At the same time, brain chemicals like dopamine and endogenous opioids, which are linked to pleasure and motivation, are activated. The striatum, which helps control movement, is also involved. This combination of emotional, motor, and cognitive activity allows children to take on different roles and explore various outcomes. In a safe space that play provides, children feel secure enough to try new things, take risks, and develop important life skills that will help them navigate real-world situations in the future. Play has also shown to support brain growth and development in powerful ways. For instance, it boosts the activity of a key brain protein called BDNF, which promotes learning and neurodevelopment. This increase has been observed in important areas like the amygdala, which processes emotions, and the dorsolateral prefrontal cortex, which is involved in thinking, planning, and decision-making. More recent studies have also found that play activates beneficial changes in brain genes expression, including a rise in insulin-like growth factor 1, a substance that helps the brain grow, repair, and stay healthy. So, play is essential for children. It's their way of learning and grow. Today, ADHD diagnoses are rising sharply, along with prescriptions for psychostimulant medications. While these drugs can be effective, their long-term effects on growing brains are still uncertain. One possible reason for this increase is a reduction in natural, self-directed play, especially in early years. Research shows that play helps children develop behavior self-control, while psychostimulants may actually reduce playfulness. Although more studies are needed, it's possible that regular, rich play could be a healthier, more natural way to support children struggling with attention and regulation. This is where you come in. As early childhood educators, you have the opportunity to shape developing minds by giving children more chances for spontaneous, self-directed play, and by gently guiding and supporting their play when needed. You are helping build the emotional, social, and cognitive foundation for a healthy future. You are supporting brain growth, you are building resilience, you are shaping lives. Thank you for the vital work you do every day.